This video is for your notes on fraction operation word problems, or SOL 6.6b. This covers pages 53 through 58. You'll need a pencil and two colors, preferably yellow and orange. When you are combining two or more groups of different sizes to find the total. So you have two different groups. Sometimes you can have more groups, but you want to put them together. This is going to be addition. When you start with the total and you take away part of it to see how much is left over. So you start with an amount and you take away something and you want to see what do you have after you take that amount away. This is a situation where you'll use subtraction. When you are comparing the sizes of two different groups to see the difference between those sizes of those groups, you are going to use subtraction as well. When you're repeatedly combining groups of the same size to find the total altogether. So if I have a bunch of groups that are the same size, I can repeatedly combine them to the total using multiplication. When you start with an amount and take a fraction of that amount, or want groups of that amount, of is the key word here. So if I have 2/3, this gray section, I can split the gray section into 4 parts, and if I want to take 3/4 of the 2/3, so I have those 2/3, I can take 3/4 of the 2/3, then I would want these 1, 2, 3 out of those 4 groups that I used, and I could do that with multiplication. So when you start with a total and you want to see how many times you could repeatedly take away or repeatedly fit in to the total, then you are taking that total and dividing it up amongst those groups. So we're going to use division. When you start with a total and you are separating it into a certain number of equally sized groups, that's another way to do division. Brandy and Gordon sold raffle tickets for their church group. Of all the tickets sold, Brandy sold 1/3 and Gordon sold 1/2. Their mother asked them, what fraction of the tickets sold did you sell altogether? What correct response did Brandy and Gordon give? So I just saw that Brandy sold 1/3 and she sold 1/3 of all of the tickets. And Gordon sold half of all of those tickets. So we want to rewrite all of the important information, and normally the important information is seen with the numbers. So if I want to know what fraction of the tickets do they sell all together, that's another key word. I'm going to rewrite some key words that tell me what I'm going to be doing with those numbers. So it's saying I want to combine the amount that Brandy and Gordon actually sold. So my action here is combining. So if I know what I'm actually doing, so if we know that the action is going to be combining, then we know that the operation that matches with that is addition. So we want to add these numbers together. Now, a lot of times, if you're having trouble with fraction operations, drawing a picture would be very helpful. So I know that Brandy sold 1/3 of the tickets, and Gordon sold 1/2 of the tickets. And I want to put those two amounts together. But those size pieces are kind of difficult to use. So I'm going to take the amount that Brandy had, which was 1/3, and I'm going to find a common denominator. Okay, so I need to find a common denominator that will be easy to split those up into smaller pieces, and I can split Gordon's amount into the same number of pieces so they're all the same size. And I see if I multiply 2 by 3, I can get 6, and 3 times 2 is 6. So 6 is going to be my common denominator for this addition problem. So I would have to multiply the top by 3 and the top by 2 up here. So I see that 1/3 equals 2/6. And when I do 2/6, we see that that's about the same amount. It's the same amount. And here, 1/2 is going to become 3/6. So now we need to combine those. We want to put the 2/6 plus the 3/6. We're going to put those things together. So my actual addition problem is 1/3 plus 1/2. I'm combining those amounts, and drawing it out sometimes helps you to figure out what you're actually doing math-wise. So I would want to take 2/6 plus 3/6 now that I found common denominators, and I see that that's going to give me 5/6. And count the pieces. Brandy has 2 pieces that are the same size, and Gordon has 3 pieces. So altogether we have 5/6, and there is no mixed number or whole number equivalent to 5/6. A house mouse is 7 3/4 inches long. So that is some important information. I'm going to rewrite that important information. House mouse, 7 3/4 inches. And a common rat is 18 1/8 inches long. That's another number that's probably important, so I'm going to rewrite that information. So the rat is 18 1/8 inches. How much longer is the rat? So here it looks like I'm comparing. So if I'm comparing 2 different groups, and I want to see something that's longer, and I'm comparing these 2, then I want to know what the difference is between a rat and a mouse. And when we're trying to find the difference, subtraction is associated with the difference. So when I'm finding and when we're setting up this problem, we always want to put the larger group first when we're finding the difference between a larger group and a smaller group. So 18 1/8 minus 7 3/4 is the problem that we're actually going to be doing. Now, let's draw a picture so we can kind of imagine what's going on. And if you're having trouble with the actual fraction subtraction, then drawing a picture should definitely help. Now, I'm going to draw a bunch of boxes. And you could draw circles, you could draw a line, but I'm going to draw one box for each inch that's represented by this mouse. So I'm going to draw 18 boxes and 1/8 of another box to show that 18 1/8 inches. So we have 5, 10, 15, 16, 17, 18, and 1/8 of another box to represent all of the inches for that rat. And I'm going to color them in with a highlighter to show how many inches the rat has. Now, we are going to compare how much the rat has to how much the house mouse has. So I'm going to match up as much as I can and see what is left over, or the difference between the rat and the house mouse. Now let's kind of show this, how to do it with the picture along with the math, so we can see why we're doing what we do to find out the answer to this problem. I like to rewrite addition and subtraction vertically so that I match the fractions up. And with addition and subtraction, we always need common denominators. So I'm multiplying the top and bottom by 2, and I get 1/8 minus 6/8. Now, I only have 1 of these 8s, and I want to take away 6 of these 8s. So I need to do something else, because I can't take 6 away from 1. There's only 1 piece there. So I'm going to cut this up. So I'm going to take one of the boxes away from this 18, and now there's only 17 boxes that aren't cut up, 17 whole boxes. And I'm going to cut up another box, but I just made 8 more 8s. So now I have 9 8s. So if I have these 1, 2, 3, 4, 5, 6, 7, 8, 9 8s, I can start taking away 6 of them. So 9 8s take away 6 8s. I'm going to cross out 1, 2, 3, 4, 5, 6 of them, I see that I have 3 left over, and 9/8 minus 6/8 is 3/8. Now I have these 17 boxes, so I'm going to take away 7 of them. And 17 minus 7 we see is 10. So all of the pieces with X's on it are the inches that the house mouse matched up with the rat. But everything that's left over is showing how much bigger the rat is. So we see that the rat is 10 3/8 inches longer than the rat. And if we wanted to write that as an improper fraction, we would do 10 times 8 is 80, and 80 plus 3 is 83. So you could also kind of see that as being 83/8 of inches. There were 5 7/8 bottles of grape juice left over after Courtney's birthday party. So this seems important because numbers are normally important in a word problem. So grape juice, we have 5 7/8 bottles. Courtney asked Jenna to take some of these bottles home. So some of these, and these is referring to the grape juice. So there's 5 7/8 bottles of grape juice, and Jenna is taking some of those 5 7/8 home with her. Jenna is going to take 3 3/4 of 3 3/4 bottles home. So then it's saying, how many bottles of grape juice does Courtney still have? So how many bottles of grape juice does Courtney still have? That's what we're actually trying to find. So let's write down what we're actually trying to do. We want to know how many of the bottles of grape juice Courtney still has. And that means that we want to know how much did Courtney have left over after Jenna took some of her bottles of grape juice. So whenever you're looking at left over, we're seeing that Jenna is actually taking away those bottles. So if you're physically taking away something, that's going to be subtraction. So you always want to start with how much did you have. So Courtney had 5 7/8 bottles, and then Jenna took 3 3/4. So the order that we're putting this in is very important. So I'm going to use the boxes again to show how much we have. So I have 1, 2, 3, 4, 5, and 7/8 bottles. Now this box is representing 1 bottle instead of 1 inch like in the previous problem. So I'm going to kind of color in how much I actually have so I remember how much I have. So there's 5 7/8 boxes to represent the 5 7/8 bottles. Now Jenna wants to take away the 3 3/4. So let's set this up and show what's going on with the picture and the math at the same time. So I have the fractions that are lined up and the whole numbers that are lined up. So I have 7/8 and I want to take away 3/4. But I don't know how many of those 8s I want to take away. So I'm going to find an equivalent fraction by multiplying the denominator and the numerator by 2. And I found my common denominator at 8. So I want to actually take away 6 of those 7/8. So I'm going to cross out 6 of those 7/8, and I see that I only have 1/8 left over. So 7/8 take away 6/8 will give me 1/8 left over. Now that we've taken care of the fractions, we can move on to the whole numbers. If I have 5 bottles and I take away 3 bottles, then I see that I have 2 whole bottles left over. So we see that Courtney still has 2 1/8 bottles. Make sure you remember what your answer actually is. It's not 2 1/8 inches anymore, it's 2 1/8 bottles. If I wanted to change that to an improper fraction, I would go 2 times 8 is 16, and 16 plus 1 is 17. And you can see that there's 17/8 bottles. Brian ate 1/3 of a cheese pizza. That seems like important information, so I'm going to write that down. So cheese is 1/3. So 1/3 of a cheese pizza. 1/3 of a pepperoni pizza. So pepperoni is 1/3. And so 1/3 of a pizza and another 1/3 of another pizza. And half of a sausage pizza. So sausage, he had 1/2 of that pizza. Brian seems very hungry. Okay, and it's saying how much pizza did he eat altogether. So altogether means that I am going to be taking all three of those amounts, putting them together, and combining them together. So he's physically combining all of that in his stomach, and we want to know how much did he actually eat? How much is in that stomach? So the actual action that we're doing is we're combining all of that pizza that he ate. And combining is always addition. So we know that we're going to do 1/3 plus 1/3 plus another half. Now, even though it says 1/3 of a pepperoni pizza, we don't have a number associated with that pepperoni pizza, so we can't take 1/3 or fraction of something. That's why it's combining instead of the fraction of model. So I'm going to draw this out. I have 1/3 of a cheese pizza. I have another third of pepperoni. So those are the same size pieces because they have common denominators. But I can't really draw the sausage on the same pizza because the sausage doesn't have the same common denominator as the pepperoni and cheese. So I know that I need to get a common denominator, and 2 times 3 is 6. So 1 times 3 is 3. 1/2 turns into 3/6. 3 times 2 is 6, and 1 times 2 is 2. So 1/3 turns into 2/6. And 1/3 is going to change into 2/6 once more. Now I'm going to add all of those amounts. So if I have 6, I can draw the 6, and I see that the cheese is going to take up 2 of those 6. So I see sausage will take up 3 of those 6. Pepperoni will take up 2 of those 6. And cheese will take up 2 more. So I kind of put those both into common denominators, and I want to combine all of those amounts. I already combined the pepperoni and the cheese. Now I want to combine the pepperoni and cheese with the sausage. So if I have 2 plus 2 plus 3, I have 7 of those slices. So I have 2 6 are pepperoni, 2 6 are cheese, but 3 6 are sausage. So I need one more pizza pan to see where that sausage is going to go. So I have one whole pizza and 1/6 of another pizza, or 7 slices that were cut up into 6. So we could have 7/6 of a pizza or 1 1/6 pizzas that Brian ate. Each magnet distributed to a class of 28 students. So we're distributing magnets to each of these 28 students, and that sounds like some important information. So we need to rewrite that there are 28 students and organize this information. So we know that each of those 28 students, so each student gets one magnet. Now if we read further, we see that each of those magnets weighs 5/16 of a pound. And it's asking us how much did all 28 magnets weigh. So we are going to take the weight of one magnet and combine it with all 28 of the magnets that we passed out to each of these 28 students. So we're trying to find the weight of 28 magnets combined. So each one has the same weight, and I am repeatedly combining that same weight over and over again 28 times. That's why we have that our action is repeatedly combining. And we can add this up 28 times, but multiplication is the quicker method. So we have 5/16, and we want 28 groups of that combined. So let's draw this out, and I'm going to draw one box to represent 1 pound. And I have these pounds that are split up into 16ths. So I'm going to split my box into a 4x4 box to make 16 smaller boxes. And I'm going to be adding each weight of those magnets. So I'm going to color in 5 of those 16ths because each magnet weighs 5 out of the 16 pieces that I broke that pound up into. So we see that the first magnet weighs 5/16 of a pound, and the second magnet weighs 5/16 of a pound, and every magnet up to that. So we have magnet 1, magnet 2, and I'm doing some dots to show that there's a lot in between there, but all the way up to the last magnet, or magnet 28, that was given to the 28th student, they will all end up weighing 5/16 of a pound. And we're adding all of those up together because I'm combining, but I'm repeatedly combining, so the faster way to do this would be multiplication. So I'm adding 5 of those 16ths every single time. Because those denominators are the same, we know that we have 5/16, and times 28 over 1, we see that we have those 5 28 times. So 5 plus 5 plus 5, all the way 28 times. 28 times 5, make sure we carry that 4, and we get 140. So we know that we have 140 of those 16th pounds. But then we need to make sure we simplify all of our answers. So we have the 140 and 16 are both even, so we will divide by 2. 16 divided by 2 is 8, and 140 divided by 2, 2 goes into 14 7 times, and 2 goes into 0 0 times. It's even again, so we could divide by 2 on the top and bottom. 8 divided by 2 is 4, and 70 divided by 2 is 35, and now they're not even anymore. I can't put 3 in there, or 5, or 7. So I know that this is my final simplified answer for my improper fraction. So I have 35/4 pounds. But that sounds weird. That's not normally how we talk about pounds. I talk about how many pounds someone is. I don't count how many fourths of a pound someone is. So if I count by 4s, I can kind of see how many times 4 goes into 35, and 35 is in between 32 and 36, so it goes in 1, 2, 3, 4, 5, 6, 7, 8 times without going over 35. So I have 4 times 8 is 32. So we have 4 times 8 is 32, but I need 3 more to get to that 35. So 32 plus 3 is 35. So now we have 8 3/4 of a pound of magnets. A line of footprints was 42 inches long. So that's some important information. We've got that this line is 42 inches long, and we're going to rewrite that information. And we know that it's a line of footprints. It's a line that's made up of footprints. And each footprint, so one footprint, was 3.5 inches long. and it's saying how many footprints were in the line. So it's saying how many of those footprints can fit on that line. So if we have a line and we have a footprint and we have another footprint, and another, we are trying to see how many times it fits in. So we see that it fits in once. We see that it fits in twice. We are repeatedly seeing how many more footprints we can fit in. So the action that we're doing here is that we're repeatedly fitting in these footprints. And that action is matched with division. So setting up the problem, we know that we have 42 inches. We always want to start with what we have. And then we are fitting in, or dividing, that line up into footprints that are 3.5 inches long. It's very important that we put the 42 first, because that's the amount that we have. We have the line, and we're dividing that line up into the number of footprints that we have, or the size of the footprint that we have. And we want to know how many footprints were in that line. So if we're drawing a picture, we can draw a number line. There's you could draw circles, boxes, anything to represent that. And if we're talking about inches, I'm just going to stick with boxes because that's what I feel comfortable with. If you want to do a number line, you could do that as well. So I'm going to draw a box, and each box is going to be represented by 1 inch. So I drew 1, 2, 3, 4, 5, 6, 7 on the top, and I'm drawing 1, 2, 3, 4, 5, 6 on the side, and a 6 by 7 grid will give me 42 boxes. And those 42 boxes are going to represent the 42 inches that are on that line. I just don't have enough space to draw 42 boxes in a straight line. So I'm going to represent it in a grid instead. So I almost have those 42 boxes drawn. And we have all 42 of those inches. So now we want to see how many times I can fit 3.5 inches in. So I'm going to use 2 different color highlighters to see how many times I can fit my 3.5 inches into those 42 inches. So remember, each box equals 1 inch. So I'm going to color in 3.5 of those boxes to represent 1 footprint that is 3.5 inches long. Then I'm going to color in another 3.5 to represent the second footprint. And I'm going to keep on doing this. I have my third set of 3.5, my fourth set of 3.5, and each of these sets is representing one of the footprints that is 3.5 inches long. So I'm seeing how many times that 3.5 inches will fit onto the 42 inches. I have my 9th set and I have my 10th set of 3.5. Then down here in the yellow I have my 11th set, and the orange is my 12th set. So it fits in perfectly 12 times. So that means I can fit 12 footprints that are 3.5 inches long on that line that has 42 available inches. So let's kind of see what this looks like as a division problem. So I have 42 is the same thing as 42 over 1. And we need to change 3.5 to a fractional form. So 2 times 3 is 6, 6 plus 1 is 7, and 3.5 is equal to 7/2. My next step is going to be KFC, so we always keep the first fraction the same. We always flip the second fraction. We always change it to multiplication. Now that we rewrote it as a multiplication problem, we can multiply 7 times 1 on the bottom and 42 times 2, which is 84, on the top. So now we have 84 sevenths. My next step is going to be to simplify. So I have 84/7, and I know that I can divide the top and bottom by 7. And 84/7 becomes 12 wholes, or 12 over 1. And that is equal to 12. So we know that 12 footprints, 12 whole footprints, can fit. So the teacher has 11 2/3 minutes left in his classroom period. So let's rewrite this information and label it appropriately. 11 2/3 minutes in class. Each student needs 5/6 of a minute to make a brief presentation. So we have that each student is going to get 5/6 of a minute. And we want to know how many students can present in the allotted time. Now, allotted means the given time, the amount of time that we have. So we want to know how many students can fit into, how many student presentations can fit into what's left over in class. So if we want to know how many students fit, we fit the first student in, then we try to fit the second student, and then the third, and then the fourth. So we are actually repeatedly fitting in these students, and that model is going to be division. So with division, we start off with how much we have. We have 11 2/3 minutes in class, and we are repeatedly fitting in or dividing that time amongst students and giving each student 5/6 of a minute. So that is our division problem. And we can start off by drawing a picture, or we could start off by just doing the problem. So let's try to do the problem first and verify it or check my answer with a picture. So I need to change both of these into fractional form. 11 times 3 is 33, and 33 plus 2 is 35. So 11 2/3 becomes 35 thirds, and 5/6 is already in fractional form. Once we get both of these into fractional form, we can do KFC. We keep the first fraction the same, we flip the second fraction, and we change this to multiplication. We can multiply across. 3 times 5 is 15, and 35 times 6 is 210. Now that we have 210 over 15, we can start dividing, and I see, to simplify, and I see that they both end in 0 or 5, so I know that I can divide the top and bottom by 5. 15 divided by 5 is 3, and 5 goes into 21 4 times with 1 left over, and 5 goes into 10 2 times with none left over. So we know that that goes in evenly. But I also see that 3 will go into both of these numbers. So 3 divided by 3 is 1. 3 goes into 4 1 time with 1 left over, and 3 goes into 12 4 times. So 42 divided by 3 is 14. So we kind of see that we're going to have 14 whole students that can fit in, or just 14 students can give a presentation in that amount of time that we have for class. Let's switch up our picture a little bit. Let's try circles. It doesn't matter what shape you use or what method you use, as long as your fractions are represented appropriately. So I have 4, 8, 9, 10, 11, and 2/3 of a minute left in class. So I don't have that last third of a minute. So I'm going to kind of cross that out because I don't have that. And I want to see how many times I can split it up into 5/6. So I'm going to split that last piece into 6. So I can kind of see how many 6 can fit in there. And 2/3 is going to be equal to 4/6. So that 1/3 that I don't have, or the 2/6 that I don't have, I'm going to cross those both out again. And I'm just going to go through and cut all of these up into 6. Because if it's the same denominator in a picture, it's much easier to do. So splitting all of these up into 6, and I'm going to see how many times I can fit 5/6 in there, and then count how many times I'm fitting them in. So I'm going to take a highlighter and I'm going to count 1, 2, 3, 4, 6, but I want my 5th, 6th over here. So if I put these together, that's going to be the amount of time that one student needs. So that's going to be student 1. And these other 5/6 of a minute will go to student 2. So we're going to keep coloring in 5/6 of a minute at a time. And remember, each circle is worth 1 minute. So I've got 5/6 of a minute for student 3. I have another 1, 2, 3, 4, 5, 6 of a minute, and that will go to student 4. I have another 5/6 of a minute, and that will go to student 5. I have 1, 2, 3, 4, 5, 6 of a minute to go to student 6. Another 5/6 of a minute to go to student 7. And another 5/6 for student 8. And we're going to keep on going and counting out how many times I can fit 5/6 into that 11 2/3. So we have student 10 and student 11. We have student 12, another 5/6 for student 13, and the last 5/6, it fits in evenly. So we have that exactly 14 students can fit into the amount of time that we have left in class for their presentation. Linda won 25 stuffed animals at the fair. So let's write this down. 25 stuffed animals. And then she gave 3/5 of, that's a fraction of, the stuffed animals. And we know that the stuffed animals, that there's an actual number that goes along with that. There's 25. So I'm taking a fraction of the amount of stuffed animals. So a fraction of a number is going to be a multiplication problem. And it's saying how many stuffed animals did Linda give to her cousin. So I want to take 3/5 of the 25 stuffed animals. And I want to know how many stuffed animals that is. So I want to know how many Linda gave to her cousin. So I have 25, and I am taking 3/5 of the 25 stuffed animals. So let's kind of draw a picture to see what's going on here. And I'm not going to draw 25 little teddy bears. I'm just going to use a circle, which is much simpler, to represent one stuffed animal. So I'm going to draw a 5x5 grid. And remember, each of these circles is going to represent one stuffed animal. So now I have 25 stuffed animals that are represented. Notice how I label everything so I remember what's going on and what is represented by what in my picture. So now that I have 25 stuffed animals, I want to take 3/5 of that, which means I need to split it up into 5 equal groups. And there's 5 equal groups of 5 for each column. So I have 5 equal groups, and I want to take 3 out of those 5 groups. Now let's count how many stuffed animals that is. When we count them all up, we see that we have 15 out of the 25 stuffed animals. And let's double check that with the math. We have 25 times 3/5, and I'm going to rewrite 25 as 25 over 1. And now they're both in fractional form. 1 times 5 is 5, and 25 times 5 is 75. And if we simplify that fraction by dividing the top and bottom by 5, then 5 goes into 5 one time, 5 goes into 7 one time with 2 left over, and 5 goes into 25 5 times. So we get 15 whole stuffed animals. And in our picture, we see where those 15 stuffed animals are coming from. Robin and Terry each bought a box of chocolate. There were 22 ounces of chocolate in each box. So that's pretty important. So we have that Robin bought a box of chocolate, and Robin's box was had 22 ounces of chocolate, and ounces is abbreviated OZ. And Terry bought one of these boxes as well. So Terry's box has 22 ounces. So they're the same. And it's saying that Robin now has 1/4 of the box of chocolate left. So we're taking 1/4 of the box, and we know that the box is 22 ounces. So we know that we're taking 1/4 of that 22. We're taking a fraction of an amount or a number. So we are going to take 1/4 of Robin's box to see how much Robin has. And Terry had 1/5 of the box of chocolate. So we have 1/5 of that box that we know is 22 ounces. And it's saying how much chocolate do Robin and Terry have all together. So we want to put Robin's amount and Terry's amount together, but we don't know how many ounces of chocolate each of them have. So it seems like we have a few steps to do here. So the first thing that we need to do is figure out how much does Robin have. So if I'm trying to figure out how much Robin has, she has 1/4 of the 22 ounces. So for figuring out how much Robin has, we're going to take a fraction of the box, which is going to be multiplication. We're going to do the same thing for Terry. So Terry, we're taking a fraction of the box, which is another multiplication problem. So we figure out how much Robin has, we figure out how much Terry has. Once we figure out how much each of those two have, we want to combine the amount that Robin and Terry have together. And that last operation is going to be addition. So let's, instead of drawing this out, sometimes it's just quicker to organize the work, and instead of drawing a picture for everything, but you could definitely draw a picture for different parts of this if you're having trouble. So we have Robin, and we know that she has 22 ounces of chocolate to start off, and now she only has 1/4 of that 22 ounces. And let's just kind of set this up a little bit better. We're going to figure out how much Robin has over here. We're going to figure out how much Terry has over here. And then we're going to figure out how much Robin and Terry have together. And once we're done with that, then we'll be done with the problem. So let's go back to Robin. We have 22 ounces of chocolate, and we want 1/4 of those 22 ounces. So we're going to put them both into fractional form, 22 over 1, and 1/4 is already a fraction. So 22 times 1 is 22, and 1 times 4 is 4. So we have 22/4, and it's easier to work with numbers that are simpler or smaller. So we are going to simplify 22/4, dividing the top and bottom by 2 because they're both even numbers. And 2 goes into 22 11 times, 2 goes into 4 2 times. And we see that we have 11 halves, or 5 times 2 is 10, 10 plus 1 is 11. So we see that Robin has 5.5 ounces of chocolate left in hers, in her box. Terry only has 1/5 of those 22 ounces. So we put them both in fractional form. 22 times 1 is 22. 1 times 5 is 5. And we have 22/5 as our improper fraction. And a lot of times simpler numbers are easier to work with. So we are going to simplify this to a mixed number. And 5 times 4 is 20. 20 plus 2 is 22. That's how we got 22/5 into 4 2/5 ounces. So we know Robin has 5.5 ounces and Terry has 4 2/5 ounces. But if we want to know how much Robin and Terry have, we need to add those two amounts together. So I'm going to rewrite this vertically and look at the fractions. So the fractions don't have common denominators, but I know that 5 times 2 is 10, so 10 could be our common denominator. So 5 times 2, and we'd have to multiply the numerator by 2 here to get 4/10, and then 2 times 5, multiply the numerator by 5 as well, and we get 5/10. So now if you have 5/10 of an ounce and 4/10 of an ounce that we put together, then altogether we'll have 9/10. And then 5 plus 4 over here is equal to 9 as well. So now we know that altogether Robin and Terry have 9 and 9/10 ounces of chocolate left over. So if we write that as a mixed number, we have 9 and 9/10 ounces. And if you wanted to look at how many tenths of an ounce they have, we could put it into an improper fraction. 10 times 9 is 90, and 90 plus 9 is 99. So they have 99/10 of an ounce, or 9 whole ounces. Julia and Marie are each making a different punch. Julia is combining 2 3/4 cups of 6 different juices. So let's write that information. So Julia's punch, we are combining 2 3/4 cups, and we have 2 3/4 cups of juice. So there's 6 different juices that we have 2 3/4 cups of. And Marie's punch starts off with 2 1/3 cups of punch. So Marie has 20 1/3 cups of punch, but then she drains, or she pours out, 3 1/3 cups of residue. Residue means left over. So she takes away 3 1/3 cups of like gross residue stuff. And then it's asking how much more punch does Marie have? So we want to know how much more. So after we figure out how much Julia has and Marie has, we want to know the difference between the amount of punches that they have. So Julia is combining 2 3/4. So you could go 2 3/4 plus 2 3/4, 2 3/4, 2 3/4, 6 different times. But because we are repeatedly combining these juices 6 different times, it would be faster to use multiplication. Now for this, so that will give us how much Julia has. And Marie, we start with 20 1/3 cups, and then we are draining or taking away 3 1/3 cups. So the model that Marie is using is the taking away model, and that's represented with subtraction. Now the third thing we're going to do is we're going to compare the difference between how much Julia has and how much Marie has. So the difference model is a different model of subtraction. So we're going to figure out how much Marie, because she's got more, minus Julia, who has less. So let's kind of draw this out in an organized way. And we're not going to draw any pictures for this one because it's a lot of work, especially for the multi-step questions. So we're going to organize this, and we're going to give ourselves some space to figure out how much Julia has, then how much Marie has. Then we're going to find the difference between Marie's amount and Julia's amount. So first, Julia has 2 3/4 cups, and she has that for 6 different juices. So she combines that 6 times. So we're going to put that in fractional form, and 4 times 2 is 8. 8 plus 3 is 11, and 6 wholes is 6 over 1. So it's in fractional form, then we multiply across and get 66/4. So for 66/4, we can simplify that so it's easier to use later. And 4 divided by 2 is 2. 66 divided by 2 is 33. And putting it in mixed number form, 2 goes into 3 one time with 1 left over, and then 2 goes into 13 6 times with one other left over. So 2 times 16 is 32, plus one more is 33. So we see that Julia has 16 and a half cups of juice once she combined her juice 6 times. So Marie starts with 20 and a third, and then she takes away 3 and a third. And 1/3 minus 1/3, we can take that away, and we get 0 thirds. And then we have 20 minus 3 is going to give me 17. So I could borrow, and then 10 minus 3 is 7, and 1 minus 0 is 1. So we see that there's just 17 cups of juice in Marie's punch mix. So we know that Marie has more, so we're going to put her amount first. We put the bigger amount first. And we have 17 whole cups, and we're taking away 16 and a half cups to see how much more Marie has. So I have 0 halves, and I want to take away 1 half, which I can't do. So I'm going to borrow 1 from the whole cup. So I'm going to take 1 cup away, and now I have 16 cups. And I'm going to add that 1 whole. So 2 halves is the same thing as 1 whole cup. So if I had 0 halves and then I add 2 halves, I have 2 halves. So 2 halves minus 1 half would give me 1 half. Now 6 take away 6 is 0, and 1 take away 1 is 0. So I see in the end that Marie has 1 half of a cup more than Julia. And I cannot write that as a mixed number or whole number.